In the hours after 3I Atlas passed its closest distance to Earth, astronomers expected quiet. The comet had streaked past on a hyperbolic trajectory, graceful, indifferent, and fast. There were no close flybys, no tail crossings, no media-worthy celestial drama. Its trajectory had already taken it past the Sun, and now it had moved safely beyond Earth's orbital path. The excitement, most assumed, was over. But something strange began happening, not in the skies directly, but in the frequencies below them. It started at a small observatory in northern Canada. A team monitoring atmospheric radio emissions noticed a low, but unusually persistent hum in the VLF range, the very low frequency band used to track natural background radiation. These frequencies are often flooded with ambient electromagnetic noise from lightning storms, solar winds, and distant quasars. But this was different. The signal was smooth, stable, centered around a single harmonic, and most importantly, it wasn't fading. The team logged the anomaly and filed it away as terrestrial interference, until the same pattern was picked up in Australia, and then again in Japan. Stations that had no connection to each other, on opposite sides of the planet, began recording the same band, a resonance hanging in the air just below the threshold of usual natural activity. It wasn't strong, it wasn't loud, but it was consistent. Some initially assumed it was an echo from the tail. Comets can leave ionized particles behind, especially in the upper layers of Earth's atmosphere, forming momentary electromagnetic traces as they pass. But this didn't behave like residual ionization. It didn't fade. It didn't move. It sat, anchored to the location where 3I Atlas had just swept past, almost like an afterimage too stubborn to vanish. Radio observatories brought in filters, and when the signal was isolated from the noise, its fingerprint looked almost manufactured. Not because it encoded any information, not because it resembled a signal in the traditional sense, but because of what it didn't do. It didn't scatter. It didn't shift. It didn't pulse erratically like auroral sounds or geoelectric interactions. Instead, the frequency remained pinned, centered on a region of sky that no longer held the comet. By the evening of December 27th, atmospheric researchers from 4 different continents had all confirmed the same phenomenon, a silent, persistent hum embedded within the Earth's ionospheric data, coinciding with the exact time and location of 3I Atlas's pass. And still, no one could explain what was producing it. Theories began to circulate. Could it be a relic from the comet's tail? Could charged particles from Atlas be interacting with Earth's magnetic field in a way we hadn't modelled before? Could the object have released some kind of long-duration plasma that clung to the boundary of our atmosphere? One researcher noted that the band resembled what happens in the moments after a spacecraft conducts a controlled burn through Earth's upper exosphere, an energetic echo that lingers for a few hours as particles stabilize. But Atlas was no spacecraft, at least not officially. Still, the hum persisted, low, consistent, and unchanging. And in that silence, something became clear. While the comet had passed, it had not left cleanly. It had brushed something, stirred something, left behind a footprint that couldn't be seen but could be heard if you knew where to listen. It was the kind of silence that didn't imply absence. It implied residue, a signature. Not the kind you sign with ink, but the kind you leave behind with presence. And that was only the beginning. Long after 3I Atlas had moved past Earth's vicinity, a quiet but peculiar pattern lingered. Not in the stars, but in the upper edges of our own atmosphere. The thermosphere, a region that begins around 90 kilometers above the surface and stretches far into near space, is where solar radiation and particle interaction shape the delicate balance of our planet's electromagnetic boundary. Satellites, auroras, and radio waves all dance within this high-altitude zone, silent, invisible, but essential. It was here, on the morning of December 27th, that atmospheric scientists detected something unusual. At first, it came in as a routine data anomaly, an elongated region of elevated ion density in the upper thermosphere. Satellites passing overhead recorded higher than expected levels of ionized oxygen and nitrogen. These are not rare in themselves. Charged particles in the thermosphere fluctuate regularly due to solar wind activity, geomagnetic storms, and atmospheric tides. But this one didn't behave like a typical ion storm. The pattern was narrow, almost surgical in shape, A strip, not a spread. Spanning thousands of kilometres in length but only a few dozen wide, like a ribbon stretched taut across the sky. And its position was oddly specific, precisely aligned with the calculated tail trajectory of 3I Atlas as it passed Earth. Initially, models dismissed the finding. Comets leave ionized trails, yes, but not like this. Traditional comet tails disperse as they drift. The further they travel from the nucleus, the more chaotic and disorganized they become, stretching into fine filaments of gas and dust carried by the solar wind. This pattern, however, didn't disperse. It held its shape. Even more curiously, it remained static for hours. Ionospheric bands usually shift and ripple in response to solar pressure. This one didn't move. It hovered, almost as if pinned by something that was no longer there. Researchers at the European Space Agency ran spectral analysis from orbital sensors aboard the swarm satellites. The results showed that the band had unusually high coherence. The ion particles within it were aligned, spinning, yes, but in the same direction, as if something had passed through and organized them into formation, a rare phenomenon typically only seen after high-energy particle collisions, or in the wake of spacecraft ion propulsion systems. But there was no spacecraft. There was only the fading path of 3I Atlas. Atmospheric physicists proposed several ideas. One hypothesis suggested that Atlas's carbon-rich tail material, when interacting with the outer edges of Earth's magnetic field, might have deposited temporary charge gradients. Another theory speculated that the comet had expelled something with an unusually high electrostatic potential, an exotic molecule or dust compound that temporarily altered the local ion balance. A third idea was simpler, but more provocative. Perhaps the structure wasn't caused by matter at all. Perhaps it was left behind by an electromagnetic field. Some speculated that if 3I Atlas possessed even partial conductivity, or if its body behaved like a capacitor in the intense radiation of space, it could have generated a residual field strong enough to polarize nearby particles. Not with force, but with alignment. Not leaving behind debris, but orientation. Days later, as solar wind resumed its usual rhythms, the band finally began to disperse. Slowly, reluctantly. Like a structure unthreading itself one atom at a time. But before it vanished, satellites captured its full length, and when the data was overlaid with Atlas's flight path, the match was near perfect. Whatever had created it hadn't been accidental. The alignment was too precise, the shape too narrow, the duration too long. It wasn't a trail, it was a wake, and it suggested, quietly but unmistakably, that 3I Atlas had done more than pass through space. It had touched something behind it, and left the sky changed. By December 27th, most expected the show to be over. Comets, even the interstellar kind, usually deliver their most striking performances during their close encounters with stars, especially with our Sun. As they draw in, solar radiation heats their icy surfaces, triggering dramatic plumes of vapor and dust to burst outward. These jets, like fiery geysers in space, carve through the vacuum, forming tails that glow against the darkness. But once the object passes its peak solar exposure and begins its outbound drift, activity should fade, jets collapse. Outgassing weakens, the comet returns to silence, but not this time. In the hours and days after 3I Atlas passed Earth, something unexpected continued to appear through the lenses of observatories and amateur telescopes alike. The jets were still visible. More than that, they were still structured. High-resolution astrophotography from both hemispheres revealed persistent streamlines extending from the main nucleus, with angular precision rarely seen beyond perihelion. Typically, these features blur rapidly as the comet moves away from the Sun, its energy source. But 3I Atlas showed no such decline. The jets didn't disperse. They remained geometrically consistent, threading space like filaments held in tension. The emission vectors, based on comparative analysis from multiple telescope arrays, maintained their angles to within a few degrees across several nights of observation. This level of consistency was unexpected, and deeply unusual. The phenomenon prompted a quiet re-evaluation of the object's activity. At first, some theorized that these lingering structures were merely optical illusions, relic trails of previous outgassing activity caught in favorable lighting conditions. But the theory didn't hold up. Atmospheric conditions varied across observation points. Moonlight interference was ruled out, and most critically, The jets weren't just visible, they were evolving. By overlaying frame sequences taken hours apart, astronomers noticed that the jets exhibited gentle pulsations. Brightness along the streamlines varied rhythmically, not randomly. In a few instances, the luminosity increased in consistent intervals, as if the jets were still being actively fueled from the nucleus. This suggested that whatever was producing these emissions hadn't stopped working, it was still ongoing. That created a problem for existing models. By this stage in its journey, the object should have lost surface volatility. Water ice, carbon monoxide, and carbon dioxide, three of the most common cometary propellants, should have depleted significantly after the solar pass, and even if some reserves remained, they should have vented chaotically, especially after thermal stress fractured the surface. Yet 3I Atlas showed none of this chaos. Instead, it presented order. The streamlines remained narrow, their boundaries were sharply defined in infrared. Dust wasn't scattering, it was behaving, and if anything, the brightness ratios across jet vectors seemed to reflect internal consistency, as though different sides of the nucleus were still actively and proportionally releasing material. For a natural object, that would require extraordinarily stable thermal regulation and surface integrity after intense solar exposure, something not previously seen in a comet of this trajectory. But perhaps the most striking discovery came from polarization imaging. When filters were applied to isolate light behavior along the jet paths, it became clear that the emissions weren't scattering in the usual pattern. The particles within these streams were aligned, not perfectly, but enough to suggest magnetic or electrostatic cohesion. They weren't simply following momentum, something was shaping them. One observatory in Chile described the jet structures as lanes, ribbons of emission extending from a central origin point, but retaining alignment across distances that should have shredded them apart. Another team described them more plainly. They look constructed. Of course, that word raised concerns. Constructed doesn't mean artificial, but it does mean unexpected, and that's what 3I Atlas had become, a comet that refused to disorganize, a traveller that, even in departure, still held form. The solar drama may have passed, but something in its structure was still performing, and the sky hadn't yet turned away. While the visible sky offered the last traces of 3I Atlas's passage, dim jet lines and structured emissions, another layer of the atmosphere was capturing a very different kind of signature. Orbiting silently above Earth, dozens of satellites scan the planet not with eyes, but with ears, listening for thermal footprints, background radiation, and electromagnetic anomalies in bands the human eye cannot perceive. Among the most sensitive of these are the microwave arrays, instruments tuned to catch faint glimmers of energy that drift through the atmosphere like heat trails from a distant fire. And on the morning of December 27th, several of these sensors registered something peculiar. Just minutes after 3I Atlas had cleared Earth's orbital sector, a subtle but coherent pattern appeared in the microwave range. It wasn't strong, it wasn't loud, but it was distinct. A rhythmic glimmer, like the slow pulse of a heartbeat, emerged near low Earth orbit. The source was transient. It didn't last long, but it reappeared twice more over the course of an hour, each time in a slightly different position but along the same curved trajectory, the projected wake path of Atlas. The glimmer wasn't thermal in nature, that much was immediately clear. Thermal events typically bloom and decay with environmental variables, cloud cover, surface radiation, or satellite heat bleed. But this anomaly wasn't tied to ground heat or solar flux. It occurred at altitudes above the bulk of atmospheric weather patterns, in the clean corridor where Earth's outer atmosphere brushes against orbital space. More curious was the frequency of the pulses. When the data was examined across 3 satellite networks, one American, one European, and one from a private commercial provider, they all revealed the same finding. The glimmers pulsed at approximately 10-second intervals, not randomly, not biologically, but steadily, like a metronome. Some theorized this was a satellite glitch, an onboard calibration error triggering false readings, but the sensors had been quiet for days. Others suggested the pulses were caused by sunlight catching residual ice particles ejected by the comet. After all, ice crystals can reflect certain microwave wavelengths, especially if aligned by electrostatic forces. But that explanation had holes. First, no reflective trail was visible in the surrounding spectrum. Second, the glimmers didn't scatter the way fragmented ice should. And third, Perhaps most notably, they moved. With each appearance, the glimmer shifted position by several degrees, tracking not in a straight line but along a gentle arc. That arc, when mapped, mirrored the exit path of 3I Atlas as it left the Earth-Sun axis behind. It followed the same angle of departure and at the same speed. That was when a handful of analysts began asking a quiet question. Was this truly a residual field from the comet's tail? Or was something still there? Because while 3I Atlas itself was already millions of kilometers away, the glimmer moved like a traveller trailing behind. Not fast, not drifting, just gliding. Some suggested it might have been a field, electromagnetic in nature, that had become temporarily entrained within the planet's magnetic boundary. In this theory, the comet's core or tail had left behind charged particles or magnetic alignments that were now coasting in orbital layers. But simulations showed that such a field would dissipate within minutes of exposure to solar wind. This anomaly had lasted over an hour. More controversial theories emerged. What if the pulses weren't remnants of a natural trail, but hints of a companion object, a fragment, a probe, something unbound from the nucleus, but still following it? There was no visible confirmation, no reflected light, no radar ping, just a glimmer, measured in microwave silence. And then, as quickly as it had come, it stopped. At 11:09 UTC, the final pulse faded. The orbital corridor quieted, and no further emissions were detected. But for a brief window, something shimmered behind 3I Atlas, and the sky pulsed back. For days after 3I Atlas passed Earth, skywatchers and professionals alike combed through telescope data, frame by frame, mapping the wake of the interstellar visitor. Comet tails, especially those from objects with high outgassing rates, often leave trails of dust and particles behind them, stretched across millions of kilometers like long, glowing fingerprints in space. Normally those trails are predictable. The physics is simple. The comet moves forward. The particles lag behind, forming a curved arc as solar radiation and wind push on the debris. These particles continue to drift long after the nucleus has moved on. Observers often see them for days, sometimes even weeks. But this time, something was different. About 12 hours after closest approach, researchers at the Atacama Large Millimeter Array in Chile noticed a strange anomaly. A section of the expected tail was missing. Not thin, not faint. Missing. The observation wasn't immediately alarming. Telescopes, after all, are susceptible to atmospheric interference. And dust tails, particularly ones composed of fine carbon-rich particles like those trailing from Atlas, can fluctuate in brightness. But the missing section wasn't a dimming, it was an absence. When they enhanced the frames, they expected to see at least a trace of particulate reflectivity in the gap zone. Instead, they found nothing. No dust grains, no ion reflection, no polarization at all. At first, this was dismissed as a data artifact, but then a similar pattern emerged in infrared imaging from a telescope in South Africa, and again in the ultraviolet from a Japanese orbital satellite. 3 instruments, 3 locations, different wavelengths, same missing segment. When all datasets were overlaid, the shape of the gap became clear. It wasn't random. It wasn't smeared like a tailbreak caused by sudden outgassing or a collapse in emission. It was sharp, clean-edged. The void stretched across a narrow corridor of space, measuring several thousand kilometers in length, but less than 100 in width. It looked carved. This posed an immediate question. What could array part of a comet's tail? One early theory suggested solar interference. Perhaps a directional wave of solar wind had swept the dust away. But that idea quickly fell apart. Solar wind doesn't discriminate. It pushes, bends, and curls tail structures, but it doesn't create surgical voids. Others posited a gravitational interaction. Maybe a small moon or unknown body had passed through the region, sweeping the dust aside. But orbital analysis ruled out any such encounter. No object large enough to disrupt the tail had crossed the area, and besides, gravity pulls, it doesn't erase. The leading hypothesis, though still deeply speculative, is that the gap wasn't created externally, but internally. In this model, the dust was never emitted in that section at all. Rather than being cleared or pushed, it was skipped. The nucleus, for reasons unknown, either paused its emission in that precise orientation or redirected it. Some went further. A few theorists suggested the gap wasn't a natural absence, but an engineered corridor, a tunnel left behind by a field effect or perhaps even an object that passed through. In this view, the dust trail wasn't interrupted. It was parted, cleaved by something that moved through the region after the comet had already passed. A silent, invisible body gliding along the tailpath, separating dust grains like water around the bow of a ship. No light was seen, no shape was tracked, but the tail structure had a memory, and that memory recorded the shape of something that was no longer there. In the stillness of space, the absence of particles can say as much as their presence, and in this case, silence carved a signature. Something passed behind 3I Atlas, and it left the sky blank. As 3I Atlas exited Earth's vicinity, the attention of the astronomy community shifted toward deep space tracking, measuring its decaying brightness, its rotational changes, and its long outbound trajectory. But hundreds of kilometers below, a quieter kind of signal was starting to emerge. Not optical, not visual, magnetic. In the early hours of December 27th, a magnetic observatory in northern Argentina reported a small but noticeable deviation in their local geomagnetic field. The anomaly wasn't large, less than a degree of directional shift, but it was sudden, occurring over a tight 6-minute window. At first, the team assumed it was equipment drift, but the instruments had been recently recalibrated, and the deviation was well above normal thresholds for local variance. By itself, it may have been dismissed. But soon after, a similar reading came in from São Luís, Brazil, one of Earth's primary geomagnetic equatorial observatories. Their sensors registered a brief shift in the horizontal intensity of the Earth's field, peaking just after 4:30 UTC. Then, like a ripple subsiding in a pool, it faded. Within hours, reports began to surface from South Africa, Indonesia, and even as far north as Hawaii, all showing the same pattern. Slight deviations, compressed timelines, and each of them falling along a specific geomagnetic band, the near-equatorial zone that mirrored the orbital plane where 3I Atlas had just passed. It wasn't a storm. Solar data from the ACE satellite showed no coronal mass ejection, no high-velocity solar wind burst, no flares. Earth's magnetosphere, by all accounts, was undisturbed. Yet here were multiple anomalies, quiet, localized, and perfectly synchronized. Magnetic scientists began to overlay the data. When plotted together, the deviation points formed a gentle arc across Earth's surface, an electromagnetic footprint aligned with the tail trajectory of Atlas. The shape wasn't chaotic, it was elegant. Like a soft wave brushing across the planet from one edge of the equator to the other. And here's where it became more than coincidence. In the center of the arc, directly over the Pacific, was a convergence point, where the readings from 4 separate observatories peaked at nearly the same moment. This convergence occurred directly beneath the midpoint of 3I Atlas's closest approach to Earth. The data raised immediate questions. Could the comet's tail, composed of ionized particles, have interacted with Earth's magnetic field in a novel way? Dust and gas are not usually dense enough to perturb geomagnetic layers, especially from a distance of hundreds of thousands of kilometers. Comets may be dramatic, but their physical influence is usually minimal at planetary scale. Yet something had triggered those sensors. One theory emerged from a team at the University of Cape Town. They proposed that if the tail of 3I Atlas included a high concentration of magnetized particles, perhaps dust grains with ferromagnetic inclusions, then Earth's magnetic field might briefly couple with the passing structure, creating a temporary drag or resonance effect. But this model had flaws. The magnetic moments required for such coupling would be orders of magnitude greater than any measured in cometary tails, and besides, the passage was too clean, too fast. Any interaction would have trailed off gradually. This one rose and fell like a breath. Others speculated that what passed wasn't the comet's tail at all, but a field, a magnetic envelope associated with 3I Atlas itself, a structure not made of mass but of influence. If the nucleus had retained or generated a magnetic charge, perhaps due to solar induction or composition, then it might have left behind a temporary wake in the ambient geomagnetic space around Earth. A ghost field, felt but not seen. No direct evidence of magnetization has been recorded from 3I Atlas. but neither has it been ruled out. The data from December 27th suggests a presence that cannot be captured with a telescope or radar, only with a compass. And for one quiet moment the needle moved, not because of the Earth or the Sun, but because something in the sky passed by, and the world felt it. Long before we had satellites, telescopes, or probes, humanity listened to the sky in the most fundamental way possible, through air. The upper layers of Earth's atmosphere are not silent. They carry waves, pressure fluctuations, acoustic tremors, low-frequency pulses, some caused by lightning, some by earthquakes, some by rocket launches, but all of them leave trails. Infrasound arrays, networks of sensitive microphones spread across thousands of kilometers, are designed to capture these subtle acoustic waves. They were originally built to monitor nuclear detonations, but over time they've become something more, ears for the planet. And on December 27, 2025, those ears picked up a whisper. Just after sunrise in the Pacific, 4 separate infrasound stations, located in Hawaii, Tahiti, Western Australia and Ecuador, recorded what they later described as acoustic shadows drifting through the stratosphere. These weren't sonic booms, not meteor strikes. They weren't thunder or atmospheric collapse. They were more elusive, low-frequency disturbances, gentle waves. And they were moving. Each detection followed a curved westward path, aligning not with weather systems or prevailing jet streams, but with the trajectory of 3i Atlas's projected outbound corridor. The signals appeared hours after the object had cleared Earth's vicinity. Yet the acoustic trails did not behave like echoes. They had structure, width, direction. At first, atmospheric scientists believed these were refracted wave remnants, residual vibrations from upper atmosphere turbulence caused by changes in solar heating. But that theory fell apart upon analysis. There had been no solar flare, no geomagnetic storm. The sun was quiet, and the frequencies didn't match any known terrestrial events. No rocket launches, no thunder, no volcanic activity. So where had the sound come from? A research team at the University of Auckland began modelling the detections. When they reconstructed the waveforms using time of arrival triangulation, they found something startling. The pressure shadows weren't random fluctuations, they were layered. The first pulse moved west, then a second, fainter one trailed it, then a third, each separated by just over 90 seconds, each growing slightly weaker, but all moving at precisely the same speed, about 320 meters per second, the speed of sound in the upper mesosphere. That speed alone ruled out man-made origins. It ruled out ballistic missiles, supersonic aircraft, and atmospheric detonation. There was no heat burst, no expansion shockwave, just clean travelling silence. The acoustic profiles looked eerily similar to those recorded during meteor airbursts, but without the burst. There was no visual counterpart, no optical flash, no radar return, no debris. And yet, something had moved through the sky, displacing air in a coordinated, repeating pattern. Some likened it to the bow wave of a silent ship, gliding just beneath the surface, pushing water ahead of its hull. But this time, the ocean was air, and the ship, still unidentified. The most controversial theory came from a team at the Atmospheric Boundary Institute in Switzerland. They proposed that what the microphones had captured was not an object, but a field. In this model, as 3i Atlas passed Earth, it may have generated or induced a pressure wave, not with noise, but with mass. A large enough energy field, if interacting with the upper atmosphere, could compress air slightly as it passed, not explosively, but rhythmically. If the source was structured, say, composed of multiple components or lobes, then each would generate its own acoustic wake, not sound in the conventional sense, but shadow, a silent displacement in the wind, a ripple in the invisible. The pulses moved on, they crossed the Pacific, faded over the Indian Ocean, and by mid-afternoon they were gone. No voice spoke, no engine roared, but for one fleeting moment the atmosphere trembled, not from within, but from above, and somewhere high above the clouds something had passed through air without touching it, and still left it moving. Late in the evening on December 27th, under a sky that had returned to apparent normalcy, a handful of observers saw something that should not have been there. It wasn't bright, it wasn't dramatic. In fact, it might have been missed entirely. if not for its impossible shape. A curved line of reflected light appeared in the western sky, hovering just above the horizon for less than 5 minutes. It wasn't a flare, it wasn't a cloud, it was an arc. Faint, pale, and precise. The first person to report it was an amateur astronomer near Papeete, French Polynesia, using a standard 200 mesosmith refractor. He was reviewing skydrift near the tail corridor of 3i Atlas's passage, not expecting anything, just routine sky watching. But what caught his eye wasn't the object, it was what followed behind it. A smooth, semi-transparent curve appeared across his field of view, arching like a distant rainbow with no colour. He blinked, adjusted exposure, and then began taking photos. Just over a minute later, a similar report came in from the Cook Islands, then from the Chatham Islands near New Zealand. All described the same visual, a clean arc of reflected light, visible only from a narrow band of latitude, and only for a very brief window. What made the observation significant wasn't just its appearance, but the angles. When astronomers reviewed the images and plotted the orientation of the arc, they discovered something eerie. The arc was not aligned with any known source of illumination. The moon was below the horizon, the sun had long since set, and atmospheric lensing, the usual culprit for strange nighttime glows, couldn't account for the geometry or the narrow time window. There was also no atmospheric inversion layer at the observed altitudes, ruling out ice halos or mirages. In raw pixel analysis, the arc reflected a narrow band of light across the near-infrared spectrum, suggesting its source wasn't terrestrial at all. It was backlit not by a lamp or a flare, but by the stars themselves. And then the alignment was tested against one more dataset, the projected outbound path of 3 Atlas. The match was nearly perfect. The arc intersected the projected tailwake of the comet at an oblique angle, forming a smooth crescent centered along the line Atlas had followed hours earlier. But Atlas was long gone, by then over 4 million kilometers away. So what, then, was reflecting the light? Some suggested a temporary dust lens, fine particles left behind by the comet, organized into a curved structure by solar radiation pressure. But tail dust dissipates unevenly. It doesn't bend light with smooth precision, and it certainly doesn't vanish in unison. Because just as suddenly as it appeared, the arc disappeared. 1 minute it was there, subtle, ghostly, quietly brilliant, and the next, gone. The sensors at the Mauna Loa Atmospheric Observatory recorded no particulate spike, no unusual scattering, no chemical trace, just silence. A few scientists proposed the arc was a boundary, a thin reflective surface composed of aligned particles, held briefly in place by an electrostatic shell or charge remnant. But even that didn't fully explain its curvature, its cohesion, its vanishing act. Others suggested it was something more complex, the remnants of a field, not dust, not light, but geometry, etched into space itself. Whatever it was, it lasted less than 5 minutes. And yet the images it left behind showed something undeniably artificial in shape, even if not in origin. A clean arc in a sky that should have been empty, a smile carved in reflected starlight. It left no trail, no residue, no sound. But for one quiet moment the sky seemed to bend, not because of what was seen, but because of what had passed. And for those who caught it, it felt like the night had remembered something and whispered it back in light. At precisely 02:13 UTC on December 28th, magnetometers across the southern hemisphere recorded something strange, something subtle but patterned. Unlike the sharp spikes usually associated with geomagnetic storms, this signal was soft. It rose gradually, and it rotated. The first detection came from the South African National Space Agency's Marion Island Magnetometer, a remote station often used to track polar current shifts. The data feed that night looked normal, until it didn't. What should have been a steady, flat reading began to curl, slowly arcing on the plot as if someone were drawing a spiral into the graph. Just 2 minutes later, stations in Tierra del Fuego and Antarctica showed the same anomaly. It wasn't intense, barely above background, but it was patterned, and more than that, it was synchronized. The spiral appeared to rotate clockwise across the data points, as if sweeping across the globe in a silent, coordinated dance. At first, scientists assumed it was an internal calibration glitch, a corrupted sensor or feedback error. But that theory quickly collapsed when independent stations, including private magnetometer arrays and university research posts, reported identical spirals. The timestamps aligned within milliseconds. There was no solar flare, no CME, no geomagnetic activity alert. So what had passed? When the data was modelled in 3 dimensions, it revealed something extraordinary. The pattern wasn't just a local swirl. It resembled a spiralling electromagnetic helix, slowly rotating and propagating through the Earth's upper atmosphere. Not disruptive, not harmful, but present. The signal seemed to phase in and out of detection thresholds as if it were riding a modulated wave, but unlike most known magnetic disturbances, it didn't taper off. It stopped, cleanly. After exactly 11 minutes and 22 seconds, the spiral ceased across every station. No tail, no fade, just silence. When researchers tried to trace the origin point, they found something unexpected. The centre of the spiral didn't map to the Earth's core or any geomagnetic pole. Instead, its axis pointed toward the region of the sky, where 3I Atlas had passed less than 36 hours earlier. It was as if the pulse hadn't come from Earth at all, but from the shadow of something left behind. Some suggested the anomaly was a flux rope, a twisted magnetic structure sometimes expelled by comets or coronal mass ejections. But flux ropes are turbulent, irregular, they spike and decay. They do not, as a rule, produce symmetrical timed spirals. Others proposed an exotic possibility, that the object had left behind a magnetic imprint. Not a field in the classic sense, but a momentary residual pattern, triggered not by particles but by space-time distortion, a memory, briefly reactivated. There is precedent for residual electromagnetic spirals, but only in highly controlled experiments with superconducting coils or quantum magnetic mirrors, never in open space, never on this scale. Still, the data was clear. For 11 minutes and 22 seconds, Earth's magnetic shell felt something, and it turned, not violently, but in a way that could be plotted with eerie precision. The final sweep of the spiral passed over the South Pacific, and then nothing. The Earth's field returned to normal, the graphs went flat, and the stations resumed their regular reporting cadence. But in the hours that followed, whispers began among the researchers, a spiral signal, with a centre not on Earth but behind it, a signature that wasn't stormy, but elegant, not chaotic, but deliberate. Some began to wonder whether it was a call, or an afterimage, or something else entirely. For in magnetism there are rarely clean shapes. Nature is noisy, random, turbulent. But this was something else, a geometric echo of a passage already complete. The Earth had moved on, but something had circled back. At 3:41 UTC, the solar observatory aboard Japan's Himawari 9 satellite picked up something it couldn't explain. The satellite, primarily tasked with monitoring weather systems across the Pacific, occasionally captures high-resolution images of neighbouring planets when they align with its field of view. Venus, currently on its inbound orbit toward inferior conjunction, had just begun to emerge near the limb of the Sun from Earth's vantage point. The timing was perfect for long-range imaging. One of the instruments on board, a high-sensitivity visual light imager used to track solar limb flares and interplanetary scattering, recorded a frame that scientists at first thought was corrupted. In the image, Venus's crescent was visible, but beside it, hugging its sunward limb, was a shadow, not a moon, not a satellite, and not a solar aberration. It was a silhouette, barely darker than the space behind it. It curved unnaturally, as if composed not of solid mass but of bent light, and it shimmered, flickering across 5 consecutive frames, before vanishing completely on the 6th. Image analysts initially dismissed the anomaly as a lens diffraction artifact, but raw sensor data confirmed it wasn't a ghosting issue. The object, or whatever it was, had been real enough to block ambient solar photons, and its curvature didn't match anything known. Venus, of course, has no natural satellites, no rings, no dust clouds large enough to cast a coherent shadow. Yet this shape was precise, not hazy, not trailing debris. It mimicked a parabolic contour, like a crescent inside the crescent. NASA's Juno mission, still in extended operation near Jupiter, was pinged for any correlative data. Though too distant to capture Venus visually, its onboard magnetometer recorded a mild fluctuation in solar wind pressure, one that precisely aligned with the timestamp of the Himawari 9 images. The pulse wasn't directed at Venus, it was trailing something, and once again, the trajectory, when plotted, aligned with the path of 3I Atlas. That raised a more troubling question. Had something peeled off from 3I Atlas and curved toward Venus, or had something been there all along, cloaked by solar glare, waiting for the right angle of detection? This wasn't the first time planetary alignments had revealed strange silhouettes, but usually they come with explanation. Passing asteroids, background stars, light echoes. None of those applied here. This shadow moved too fast. It registered no heat signature and left no ionized trail. But it reflected just enough visible light to leave a trace on an ultra-sensitive frame, just once. And then it was gone. Researchers at Kyoto University simulated the event in volumetric rendering space. When they reversed the orbital path of the shadow and cross-referenced it with Atlas's departure vector, they noticed something impossible. The angle of movement wasn't orbital, it was tangential. It hadn't fallen toward Venus, it had slid behind it, deliberately. At an angle that avoided detection from Earth's line of sight until that brief moment of alignment, as if hiding, or repositioning. Amateur astronomers from New Zealand attempted to capture the anomaly in follow-up observations using narrowband filters, but by the time of their recordings the shadow had vanished. But one detail stood out from the original Himawari 9 data that no one could explain. For exactly 0.46 seconds, the pixels surrounding Venus's limb showed a brightening, as if something had reflected a flash. Not from the sun, but from behind Venus itself. Like a backlight from the dark. Not from a known source, and not in a natural wavelength. This was not just an optical trick, it was a presence. And though the object was gone, the implications remained. Something had been near Venus. Something that wasn't there before 3I Atlas passed Earth, and perhaps something that was no longer content to remain invisible. It was the kind of anomaly that shouldn't exist in a space so close to the Sun. At 0702 UTC, the European Space Agency's thermal imaging satellite, ORB-14, which typically monitors upper atmospheric changes and space debris temperatures, sent back a sequence of frames that lit up internal alert systems, not because they were too hot, but because they were too cold. The sensors flagged a narrow corridor of space, less than 400 kilometers wide, just beyond the orbit of Venus, where something strange had occurred. Within that region, temperatures plummeted well below expected solar exposure norms. Space, by definition, is cold, but the area in question wasn't cold due to absence of energy. It was cold in contrast, a thermal void, like a path carved through background radiation. In simpler terms, something had recently passed through and pulled the heat out with it. Engineers and physicists examining the data were initially confused. Their first hypothesis suggested a shadow trail caused by a passing object temporarily blocking solar radiation. But the dimensions didn't match. The shape wasn't consistent with any known cometary fragment or debris field, and most critically, there was no mass signature. Nothing was reflecting light in the visible spectrum. Nothing was radiating energy in the infrared. Only the temperature readings betrayed the disturbance. Imagine walking across a sunlit beach and finding a perfectly cold footprint that doesn't melt, doesn't shift, and wasn't left by anything you can see. That's what ORB-14 detected. A cold signature in the warm solar wind. In total, the path extended nearly 8,000 kilometers, curling gently like a corkscrew. The spiral wasn't random, it moved in tandem with solar magnetic fields, like it had been influenced, but not fully controlled by the sun's dynamics. But then the deeper mystery emerged. NASA's solar telescope aboard the Parker Solar Probe was able to partially triangulate that same region. Though Parker wasn't directly facing the event, its side-facing sensors caught a minor flux in charged particles, suggesting that the cold trail wasn't just a temperature anomaly, it was a plasma vacuum. Particles that would normally dance chaotically through the heliosphere were suddenly absent in that zone. Something had cleared them out. As if a conduit had formed briefly and sucked the particles into a tight, silent corridor, not ionized, not scattered, just gone. What could do that? Comets shed particles and form plasma tails, but this was the opposite, a tail that absorbed instead of emitted, A void, not a trail. Astrophysicists from the Max Planck Institute reviewed the telemetry and modelled several possibilities. A hypercooled object using directional shielding to carve a path through charged space, a cloaked structure redirecting ambient particles, or a corridor opened temporarily by some gravitational or electromagnetic manipulation. But none of these held under scrutiny. Unless the trail wasn't made by something physical, but was a byproduct of a shift in space-time properties. In recent years, high-energy experiments in particle physics have shown that certain resonance fields can momentarily warp how energy distributes in localized regions. That's on a laboratory scale. What if something out there, connected to 3I Atlas, was doing the same thing but on a cosmic scale? What if the passage of this entity wasn't just a movement through space, but a rearrangement of the medium itself? For now, there's no proof of exotic propulsion, no confirmation of artificial behavior, only a trail of cold where there should be heat, a silence where there should be particles, and a shape that moved as if it understood how to erase its presence. 3I Atlas may have passed Earth, but it didn't leave a trail of dust. It left a void, one that the planet is now trying to understand before it gets too close again. On the morning following 3I Atlas's closest approach, ground-based magnetometers in Antarctica began reporting data spikes that defied their calibration. These weren't ordinary geomagnetic storms. There were no corresponding solar flares, no CME impact from the sun, and the solar wind pressure remained normal. Yet the southern magnetic pole experienced one of its most erratic sequences in over a decade. At precisely 03:41 UTC, the Halley Research Station on the Brunt Ice Shelf flagged a rapid fluctuation in the horizontal component of Earth's magnetic field. The vector swing was subtle, but fast, like a whip cracking just beneath the crust. 10 seconds later, similar readings echoed from Vostok Station thousands of kilometers inland. Then Casey Station, then Dumont d'Urville. This wasn't an isolated spike. It was a wave. A coordinated disturbance racing beneath the icy floor of the planet's most magnetically sensitive region. What stood out most wasn't just the timing, it was the pattern. The disruption wasn't random. The magnetic shifts aligned with a spiral geometry, curving like a fingerprint laid gently across the Antarctic continent. Teams at NOAA and ESA began comparing datasets in real time. They applied reverse field modeling techniques used during intense solar storms, but nothing fit. The curves didn't match any known ionospheric resonance, and critically, no auroral activity was observed. That's when attention shifted, not to the sky, but to the space just beyond Earth. Orbital data from the Themis satellites, normally used to study substorms, showed a mild yet detectable shift in the structure of Earth's magnetotail. This tail is formed as solar winds drag Earth's magnetic field outward, creating a long, comet-like shape. But now, something else was influencing that tail, and it wasn't the sun. One of the Themis probes, THC, registered a deflection, like a tug, originating from deep within the tail's farthest extent. But there was no known object there, no moonlet, no rogue debris. The only known visitor in that region, within a plausible time span, had been 3I Atlas. It was long gone by now, or so they thought. Some scientists theorized that Atlas may have deposited something in its wake, something capable of affecting Earth's magnetic field in a localized yet precise way, a filament of exotic matter, a plasma trail with anomalous conductivity, or a fragment that hadn't been seen but was still interacting. Others were more cautious. They pointed to the Earth itself, suggesting that the close flyby, especially at the speed and angle observed, might have induced internal harmonic oscillations within the planet's own magnetic systems. In short, the planet had shivered in response. But even that raised questions. Earth's magnetic field is robust, dynamic, and has weathered solar tantrums far stronger than the subtle passage of a comet. Why would this cause a measurable disturbance in the most geologically stable region of the southern hemisphere? Unless what passed by wasn't a comet at all. Back at Halley Station, researchers noticed a curious secondary effect. Infrasound detectors, usually used to monitor ice shelf movements and remote explosions, picked up a broad, low-frequency hum during the same time frame. It lasted only 22 seconds, and no, it didn't come from the ice, it came from above, from the upper atmosphere, a resonant, subaudible vibration that seemed to originate not from Earth's surface, but from something that had interacted with Earth's magnetic skin and then retreated. A touch, perhaps, a signal, or maybe just a shadow brushing against the edge of our global systems, too soft to panic us, but too real to ignore. In the weeks that followed, global magnetic patterns stabilized. The readings faded. The anomaly was gone. But Antarctica, normally silent, frozen and still, had been briefly stirred by something that may never come that close again, or worse, might already be beneath us. The Indian Ocean was quiet that night. No major storms, no seismic disruptions, no abnormal ionospheric readings, at least not until several high-altitude weather balloons launched from Diego Garcia began transmitting unexpected data. At first, it was subtle, then unmistakable. At an altitude of over 30 kilometers, near the edge of the stratosphere, each of the balloons recorded a faint but persistent plasma layer. A band of ionized particles that should not have been there. Not at that time, and certainly not with such characteristics. It wasn't solar, it wasn't auroral, and most importantly, it wasn't noisy. Plasma in its nature is dynamic. It interacts with magnetic fields, radiates electromagnetic signals, and responds visibly to solar inputs. But this layer was doing none of that. It was behaving silently, gliding through Earth's upper atmosphere like a phantom echo. Initial assumptions leaned toward residual solar effects. But the solar wind was calm. There had been no coronal mass ejections in the past 48 hours. The sun was quiet. Yet this plasma layer moved. Satellites passing over the Indian Ocean, particularly those belonging to the DMSP constellation, reported light refraction anomalies. Laser beams used for atmospheric calibration bent ever so slightly as they passed through this plasma veil, suggesting a variable density that was constantly reshaping itself, like a lens made of fog, moving but holding together. Even stranger was its shape. From composite satellite overlays, scientists sketched a vast elliptical structure, several 100 kilometers wide, drifting with the jet stream but maintaining a distinct boundary. It wasn't dispersing like normal ionized clouds. It was cohesive, as if held together by something internal. A charge differential, a field, or something else entirely. At 3:17 a.m. GMT, ground-based radar installations in coastal India, Mauritius and Australia detected a dip in high-altitude radar returns. Planes travelling through commercial airspace noticed minor signal disruptions, not enough to raise alarms, but enough to flag inconsistencies in their onboard systems. Then came the signal dropouts. A British military communications satellite briefly lost contact while above the Indian Ocean corridor. Only for 12 seconds. But it was enough to cause a realignment of transmission protocols. Nothing else was damaged, no data lost, but that blackout window matched precisely with the densest core of the plasma ellipse. When investigators pulled telemetry, they found no solar flare, no background radiation spike, no orbital debris that could have caused the signal loss, just emptiness. That's when attention turned again to 3i Atlas. Though officially Atlas was far beyond Earth by now. Its trajectory during flyby showed a sharp gravitational slingshot that brushed against Earth's magnetosphere and dipped close to equatorial space. The Indian Ocean corridor, directly beneath that path, had been quiet at the time, until now. Several physicists speculated, what if the object had shed plasma material deliberately or incidentally during that arc? A reactive tail segment, a radiative shell, something left behind, just thin enough to go unnoticed, but stable enough to persist and travel. One theory suggested a process similar to magnetoplasma injection, a phenomenon observed in controlled fusion research, where magnetic fields trap and guide plasma into stable rings. If Atlas carried such a field, or worse, left behind a structure designed to maintain one, it could explain both the silence and the stability. But what purpose would it serve? The plasma wasn't transmitting, it wasn't reacting, it wasn't even decaying. It was simply travelling. One scientist reviewing the movement logs made a quiet note in the margin. Directional, like a scanning veil. Whether it was observation, afterglow, or a remnant of something larger, no one could yet answer. But for nearly 6 hours that silent plasma drifted across the skies of the Indian Ocean. Unbothered, undetected by the public and barely understood by the scientists tasked with watching it. By dawn, it was gone. No trace, no residue. But those who tracked it know something had passed overhead, something intentional. When an object of cosmic scale, especially one moving at interstellar velocities, interacts with a planet's atmosphere or magnetic field, the expected byproduct is dust. Not just any dust, but microparticulates, ionized debris, vaporized traces, fragments that serve as fingerprints of motion, force, and material decay. But in the case of 3I Atlas, something unusual occurred. As Earth-based dust particle analyzers such as those stationed on Mauna Loa and the Antarctic Plateau recalibrated after the object's closest pass, they reported a stark absence of what should have been there. No silicate residue, no carbon microfragments, no metallic flake scatter. It wasn't just less than expected, it was none. This lack of particulate debris left several planetary scientists puzzled. Even benign near-Earth asteroids, when passing at a fraction of the distance, often leave faint clouds of trail dust that settle in the upper atmosphere or get captured by LIDAR sweeps. But this time, nothing. At first, speculation centered on sampling error. Maybe the atmospheric sweep windows were mistimed. Maybe solar wind had carried the particles away before they could settle. But cross-checks with laser altimetry, airborne particle counters, and satellite-based debris sensors showed the same results. It wasn't a sampling error. There was no dust. But in the absence of physical debris, another pattern began to emerge. Something else was detected, though not with the typical instruments. Supercooled coherent structures. That's the term researchers from ESA's Swarm satellite mission began using when they observed something odd in the geomagnetic field lines after the 3I Atlas passage. It wasn't a physical object. It wasn't dust. It was a structured pattern of alignment, long filaments of magnetic vectors, smoothly flowing, almost as if combed by an external field. These field lines weren't twisted or chaotic like they usually are after a solar storm. They were smooth, ordered, and persistent, like invisible rails laid across the magnetosphere. One swarm scientist likened it to finding combed grass after a massive windstorm. No debris, no mud, no splinters, but the unmistakable trace of something having passed. The phenomenon was so precise that when visualized it formed concentric waves, rings of altered magnetic alignment, spreading outward from where the object passed closest to Earth's field. But if there was no material trail, how could such coherence exist? Here's where theories diverged. One school of thought pointed to field-based propulsion. If 3I Atlas operated using advanced magnetoplasma dynamics, using its own internal field to bend space or steer via magnetic interactions, then its passage might have subtly imprinted order onto the natural chaos of Earth's magnetic field without ever depositing dust. Another camp argued for coherent shielding, a concept observed in high-energy physics, where certain particle interactions cause nearby fields to align without leaving any physical trace. If the object was surrounded by a coherent field shell, it might not shed debris at all. It might repel it, or convert it into something non-material, like field vibration or quantum interference. But the most compelling theory came from a group studying Bose-Einstein condensate simulations. They proposed that 3I Atlas wasn't leaving behind matter because it was never emitting any to begin with. Instead, it moved through space-time as a coherent phase structure, a field-locked entity that behaves more like a wave than a mass. That would explain the silence. That would explain the lack of impact. That would explain the coherence. It didn't interact with Earth in the way we understand objects to interact. It passed through, not like a stone through water, but like a thought through a mind, leaving not scars but altered patterns of flow, no dust, just coherence. And now the field lines of Earth, the very fabric of our planet's invisible shield, bear the quiet memory of something that did not touch, yet still left a mark. Hours after 3I Atlas passed beyond the Earth-Moon system, seismologists in Hawaii, Japan, Chile, and New Zealand began noticing something curious. Not tremors, not quakes, but a faint, oscillating gravitational signal, subtle and rhythmic, moving steadily across the Pacific Basin. It was first detected by Japan's Kamioka Gravitational Anomaly Monitor, a highly sensitive instrument nestled deep within Mount Aquino. Its usual function was to pick up tectonic drift and pre-seismic shifts in the crust. But on this morning, it registered something else, a slow, sweeping pulse, almost like a pressure wave, but with no physical displacement. 20 minutes later, the same pattern appeared on Chile's Atacama subsurface array, then in New Zealand, then in Hawaii. Each node, spaced thousands of kilometers apart, recorded the same tempo, one faint compression every 2.5 minutes. No seismic activity, no atmospheric storm, no underwater landslide. And yet something was moving through the crust, or beneath it, with mathematical regularity. For a while, researchers thought it might be an instrument malfunction until they triangulated the signal's origin path. All wavefronts pointed back to one location, the point in space where 3I Atlas had made its closest pass to Earth, just above the equator, west of Kiribati. It wasn't just magnetism that 3I Atlas left behind, it was gravity. More precisely, a wake, like the trailing signature a massive ship leaves on still water, even long after it passes. Except this wake wasn't on the ocean's surface. It was embedded in space-time itself, dragging across Earth's mantle like a soft vibration rippling across a drumhead. The Pacific, being Earth's largest and most open tectonic plate zone, responded like a tuning fork. It amplified the pattern, allowing it to travel thousands of miles with barely any attenuation. But this was no ordinary gravitational pull. What startled researchers most was its coherence. Traditional gravitational waves, such as those emitted by black hole mergers, arrive in high-frequency, fast-dissipating pulses. What they were seeing here was low-frequency, persistent, and harmonically stable, more like a standing wave than a ripple. There were 3 working theories. First, inertial recoil. Perhaps as 3I Atlas left the Earth's gravitational influence, it created a recoil effect, an inverse gravitational bow shock, similar to what happens when a magnetic object is pulled from a field and the lines snap back. Second, gravitational memory, a controversial but increasingly studied phenomenon where massive objects leave behind a lingering echo in the geometry of space-time, a residual warping that doesn't decay immediately. If 3I Atlas was dense enough, or manipulated gravity in a non-Newtonian way, this echo might have lingered in the tectonic strata beneath the ocean. The third theory was far stranger. A group at Caltech's Gravity Wave Lab proposed that this wasn't a wake at all. It was a marker, a signal, a breadcrumb. The persistence, the rhythm, the global alignment. It didn't behave like a passive trail. It behaved like an intended pattern, as if something was mapping Earth's crust, scanning it, or embedding a frequency for later interpretation. And here's the part that broke the model. The signal repeats. Exactly every 12 hours, 36 minutes, and 18 seconds, the entire Pacific wave signature resets, like clockwork, as if responding to a distant metronome or a return signal being transmitted. Satellites try to match it with lunar or solar tidal patterns. No match. Space weather, orbital debris, submarine fault shifts, none aligned. This was external, yet rhythmic, and as of now, it shows no signs of fading. The Pacific Seismograph Network has entered a state of global watch. New algorithms have been written, new protocols drafted. Every pulse is logged, time-stamped, compared. Something moved past us. But something also stayed behind. And that something might be using the planet's own mass as a resonant body, a living amplifier for whatever message or phenomenon is still unfolding. In the hours following the Pacific gravity wake, meteorologists around the world began noticing something subtle, but undeniably strange, in the skies above the equatorial regions. Clouds stopped behaving normally. At first, it was dismissed as seasonal variability, unusual, perhaps, but not unheard of. The Intertropical Convergence Zone, a belt of low pressure that wraps around Earth's equator, often produces chaotic cloud patterns due to the convergence of trade winds from both hemispheres. But this wasn't chaos, it was order, a quiet, unnatural symmetry. From Brazil to Indonesia, satellite imagery showed cumulus clouds forming in synchronized spirals that moved with geometric precision across vast stretches of sky, as if responding to some invisible lattice. These formations weren't tied to temperature, pressure, or wind patterns. They defied the usual thermodynamic drivers of cloud behavior. But what stood out most wasn't just the shape, it was the timing. Across at least 7 equatorial nations, weather balloons launched into the upper troposphere all returned with unusual microcurrent data. Instead of the expected turbulence and jet stream divergence, they recorded stable horizontal shear bands, like narrow lanes of still air embedded within the sky. Within these lanes, cloud particles formed and moved in sync, aligning like iron filings in a magnetic field. For veteran meteorologists, the visual signature was familiar, but only from simulations. It resembled what's called a gravity wave duct, a rare atmospheric phenomenon where pressure layers trap wave energy and channel it across long distances. But these ducts usually form under extreme conditions like volcanic eruptions or strong tropical cyclones. Nothing of the sort had occurred, so the question was asked, what exactly was causing these ducts to form, and why now? The answer came not from the atmosphere, but from space-based LiDAR arrays operated by the European Space Agency. ESA's Sentinel-5P satellite, which maps aerosol and cloud profiles in the upper atmosphere, captured something stunning. At an altitude of roughly 14 kilometers, just at the cusp of the tropopause, a fine mesh-like field of high-altitude micro-reflections had formed. Not ice, not dust. Not standard aerosols. These reflections appeared in a hexagonal tiling pattern, uniform across thousands of kilometers, and strangely polarized. That is, they reflected sunlight differently depending on the satellite's viewing angle, a trait usually associated with artificial thin films or engineered microstructures. And then came the real surprise. This atmospheric layer was slowly rotating, not with the Earth's rotation, but at a slightly offset velocity, producing a drift pattern that perfectly matched the lingering orbital path of 3I Atlas during its closest approach. The implications were unsettling. Was this debris? Had 3I Atlas released something during its pass, something too small to track as objects but large enough to form an atmospheric lattice? Or worse, was this intentional? A seeding mechanism? A diagnostic layer? Something that responded to gravity or magnetism spreading only within Earth's upper atmosphere. Multiple labs attempted to analyze the refractive index of the particles. The readings came back inconsistent. Some matched fine volcanic ash. Others resembled aerogel, a synthetic ultralight compound that doesn't occur naturally. But there was another twist. Weather systems beneath the cloud anomalies began to calm. Not violently shift, not intensify, but settle. Storms weakened. Winds stabilized. Thunderhead activity dropped significantly. It was as if turbulence itself was being dampened, like a planet inhaling after a long sprint. Climate scientists warned against overreaction. This could be a short-term phenomenon, a passing anomaly. But no one could ignore the eerie synchronization, the way the clouds seemed to move like signal carriers, not passive vapor. One physicist from the University of Tokyo offered a metaphor. It's like the Earth's upper atmosphere became a display screen, and something drew a pattern across it. And that pattern might not have been random. As the world watched the skies, cloud watchers, meteorologists, and amateur photographers alike began to share the same question. What did 3I Atlas write in our clouds, and who was meant to read it? It started as a curiosity posted to a photography forum. A user in Chile uploaded 2 high-resolution images of the waxing gibbous moon taken only 72 hours apart, both under identical settings, both using the same Nikon telescope lens. But something was off. In the second image, the albedo, the measure of reflected light, had changed. Not dramatically, but in the lowlands of Mare Imbrium, the darkest basaltic plains seemed subtly brighter. The shift wasn't due to cloud cover, atmosphere, or haze. It was inherent to the lunar surface itself. At first, the change was chalked up to angle variation, but soon similar reports began flooding in, from astronomy clubs in Arizona, observatories in India, and even a weather satellite over the Indian Ocean. All noted the same anomaly, a non-random reflectivity change on the lunar surface, visible only from Earth's night side. And then came the spectrography. The Mauna Kea observatories in Hawaii, using their twin spectroscopes during a full moon window, analysed the returning light spectra from the lunar surface. Their instruments detected a faint but consistent spectral distortion in the near-infrared band. not the kind caused by dust or meteor impacts. This distortion behaved like a diffraction pattern, a splitting of light as if passing through a microscopic grid. That's when things began to feel coordinated, because at the same moment these anomalies appeared, NASA's Lunar Reconnaissance Orbiter, LRO, which had been orbiting the Moon for over a decade, returned blank imaging data from its last 2 passes over the same regions. The onboard cameras, previously crystal clear, now produced a hazy, washed-out field when directed toward the same coordinates, where Earth-based observers noted albedo shifts. It was as if something interfered with the light, not blocking it, but scrambling its return to both Earth and orbit. The official explanation? Thermal noise. But that didn't hold up. LRO's instruments had performed flawlessly through hundreds of lunar days and nights, even during higher radiation storms. This wasn't noise, it was masking. And then came the laser pings. Several universities, including MIT and the Chinese Academy of Sciences, had lunar laser ranging experiments underway, firing precise pulses at retroreflectors left by Apollo missions. Normally, these reflectors return a consistent signal with only minor atmospheric degradation. But on December 18th, their results changed. The returned pulses arrived delayed. Not by much, just fractions of a millisecond, but enough to suggest that either the surface distance had shifted, or the light was refracting through an altered medium. Neither made sense. The Moon doesn't just change shape in days, and no natural lunar phenomenon could explain a wave interference pattern in reflected light. So attention turned outward, toward 3I Atlas, which had already passed Earth and was now behind the Moon from certain southern hemisphere angles. Could the object, whatever it is, have left a residue? Not physical dust, but a structured optical field, something that, like atmospheric ionization, distorts light without being visible? One astronomer from the European Southern Observatory proposed an eerie possibility, a kind of temporary quantum lattice, formed as Atlas passed between the Moon and Earth, disrupting the coherent light return we usually take for granted. In short, the Moon was still there, but the Moon we were seeing was different. This wasn't just about observation. This was perception, about what happens when the universe starts altering the way we receive its light. Some called it a glitch, others a warning, and a few whispered that perhaps, just perhaps, something had been written on the Moon's face, and Earth was not yet ready to read it. At first, it was just a blip on social media. Hashtags like No Sleep December and Weird Dream Week began trending in scattered regions. Most were treated as jokes. Teenagers in Argentina reported waking up multiple times a night. A group of truckers in Poland complained of intense, vivid dreams. Teachers in Australia noted restless students unable to concentrate after claiming they didn't sleep right. It wasn't global, that's what made it so strange. The phenomenon seemed confined to specific latitude bands, particularly between 20 and 35 degrees north and south. These were not geopolitical zones. They cut across nations, oceans, and continents. But inside those bands, hospitals, clinics, and wearable sleep tracking apps all began reporting the same pattern. A sharp increase in REM disturbances, spike in body temperature between 2 and 3 a.m., and sudden waking without cause, usually occurring simultaneously across time zones. In other words, people in completely different countries were waking up at the same local hour, as if something external had synchronized their interruption. Fitbit, Oura Ring, and other biometric platforms aggregated anonymized data. The spike was undeniable. Even more eerie, the data pointed to a consistent waveform pattern in heart rate variability, resembling a shallow wave that rippled across hemispheres. Governments took notice. The US Centers for Disease Control, the European Space Agency, and even the Russian Federal Biomedical Agency quietly began monitoring the phenomenon under internal code names. Publicly, no official statement was issued, but in classified circles the working theory was chilling. The sleep disturbances coincided precisely with the time window when 3I Atlas crossed Earth's magnetic tail, and then came the animal behavior reports. Veterinarians in Brazil, Kenya, and Indonesia submitted similar complaints. Dogs barking violently at 3:07 a.m. sharp, horses sweating as if startled, birds flying in erratic formations before dawn. Zoos reported nocturnal animals acting disoriented, pacing in circles, refusing food. What tied it all together was the non-randomness. These weren't isolated events. They followed a silent rhythm, a pattern of disruption aligned with Earth's magnetosphere fluctuations, which themselves were behaving abnormally. On December 17th, the NOAA's Space Weather Prediction Center published a subtle anomaly in its daily magnetometer logs. The readings showed a pulsed interference, low amplitude, but not natural. It wasn't from the sun, which had been calm for days, and it didn't resemble man-made interference from satellites or radio towers. It was something else, something directional. The pulses occurred around 2:50 to 3:15 a.m. UTC, with a broadening band of disturbance in the hours following, the same window in which the sleep disruptions occurred, particularly in regions aligned with the Earth's magnetic field lines. Sleep researchers turned to EEG data. In affected zones, brainwave patterns during sleep had begun to exhibit a new frequency burst. Not delta, theta, or REM-associated alpha waves, but a short-lived gamma spike not normally seen during rest. Some hypothesized it was the result of external ELF, extremely low-frequency modulation. In plain terms, something was causing the brain to light up at night, every night, across entire continents. Whether it was due to electromagnetic interference, gravitational pulses, or a more exotic mechanism, no one could say. But one thing was clear. This wasn't psychological mass hysteria. It was biological, measurable, and, perhaps most disturbingly, localized by design. What kind of force targets specific latitude bands? What kind of signal could move through Earth's magnetic field without detection from conventional satellites? And what kind of intelligence, if any, would choose sleep as the first frontier of contact? Because by the end of the week, tens of millions had experienced the same phenomena: a sudden wakefulness, an image they couldn't quite remember, and a sound they swore never happened, a soft tone, somewhere between memory and dream, and just like that, it vanished. In the early morning of December 18th, something unexpected happened. Astronomers at Chile's Paranal Observatory, home to the Very Large Telescope, were mid-session tracking a series of faint reflections from 3I Atlas's trailing debris. At exactly 03:12 a.m. UTC, the system's adaptive optics began to struggle. Not just minor turbulence or atmospheric distortion, but a complete loss of signal acquisition. The telescope couldn't see. It wasn't a mechanical error. The sky was clear. All internal systems were operational, yet when trained on the object's calculated coordinates, the feed returned nothing but black. This was the first blackout, but within 3 hours, similar reports came in from the South African Astronomical Observatory, the Siding Spring Observatory in Australia, and even the Mauna Kea telescopes in Hawaii. A pattern began to emerge. Not every observatory was affected. Only those located within 35 degrees of magnetic equator lines, the same bands previously flagged for sleep disruption, were reporting visual failure, and only when targeting a specific sector of space now loosely associated with 3I Atlas's outbound trajectory. The strange part? Other stars in the same sector remained visible. Only 3I Atlas and the space immediately surrounding it was now shrouded in a form of visual null zone. It was as if the object had become optically stealth, not just to human vision, but to the full range of visible and near-infrared frequencies. This was more than cloaking. At the Roque de los Muchachos Observatory in the Canary Islands, technicians working with the Gran Telescopio Canarias initiated a deep scan sequence using spectroscopy and low-bandwidth scatter imaging. Their results were logged but not made public. Within 48 hours, the entire array was placed into restricted access mode by Spain's Instituto de Astrofísica. Astronomers were told the equipment was being recalibrated, but the unofficial consensus among insiders was stark. Something had switched off the sector. Space agencies began scrambling for answers. The European Space Agency issued a silent priority alert, codenamed Aegis Delta, urging partner nations to cease all civilian tracking efforts of the 3I Atlas region and await further guidance. The alert was encrypted under a now obsolete solar flare protocol, repurposed for a completely different phenomenon. But it was too late. Amateur astronomers, equipped with high-resolution CCD arrays and long-range scopes, had already picked up on the darkening. On Reddit, Discord, and obscure astronomy forums, images began to circulate, star fields with a sharp void. a shadow cutting through celestial coordinates where no known mass should be. Even stranger were the claims that followed. Several hobbyists claimed that using analog film and long exposures, they had caught negative light distortions, photographic anomalies where the background was brighter than it should be. Not a shadow, but an active absence of light. A perfect circle, a cloaked field. The speculation grew louder. Was 3i Atlas emitting some form of active field distortion? Something that didn't just absorb or scatter photons, but fundamentally cancelled their travel path? This wasn't gravitational lensing. It wasn't normal occlusion. It was a type of field interference no one could model. NASA remained silent, but behind the scenes, leaked memos from the Jet Propulsion Laboratory revealed the deployment of narrowband LiDAR satellites to sweep the sector, typically used for high-altitude atmospheric profiling, now pointed into space. And then, without warning, several of those satellite feeds were cut off mid-transmission. The final transmission from one of them, Project Scout 2, showed a brief spike in infrared energy, followed by total data collapse. Engineers described it as like someone put a blanket over the sun. The blackout spread. By the evening of December 18th, the only telescopes still able to track 3i Atlas were located at high magnetic latitudes, far from the equatorial field lines. Even then, their data became increasingly corrupted by signal echo, as if the object was emitting a kind of low-power field that bent data itself. Whatever this was, natural, alien, or some new physics, it was active. It knew how we were looking, and one by one it was turning the eyes of Earth away. As 3i Atlas continued to drift past Earth, one final connection remained. Not optical, not infrared, but magnetic. Long after telescopes were blinded and data feeds were scrambled, Earth's magnetometers continued humming with anomalies. Subtle, shifting, but unmistakable. These weren't the usual signatures of a solar wind impact or polar aurora. This was something far stranger. It started on December 18th at 2108 UTC, when Japan's Kakioka Magnetic Observatory detected a sharp, non-polar magnetic spike. Not aligned with typical solar flare behavior, this pulse seemed to originate from the magnetotail, the long night-side extension of Earth's magnetic field, stretching millions of kilometers into space like a comet's tail. This was peculiar for two reasons. First, Earth's magnetotail is normally quiet, disturbed only by substorms or major coronal mass ejections. Second, the pulse wasn't symmetrical, it twisted, following a curvature that appeared to spiral. It wasn't a flare, it was a whisper. Minutes later, Canada's Themis satellite constellation, which monitors plasma and magnetic dynamics in Earth's tail region, recorded a phenomenon it couldn't label. Slow, rotating waveforms inside the tail plasma. The satellites were silent for a beat, then transmitted encrypted diagnostics that forced a Level 4 alert at both NASA and the Canadian Space Agency. What they had recorded didn't follow any previously observed magnetohydrodynamic behavior. The rotation rate was unnaturally uniform. The waveforms didn't disperse. They maintained shape over distance. Some engineers at the Jet Propulsion Laboratory described them as coherent whispers, frequencies that stayed intact across light seconds of space, bypassing the usual noise of ionospheric deflection and solar scatter. At first, many dismissed it as interference, perhaps an echo from a prior flare, but then it repeated. Exactly 22 minutes later, the same waveform emerged in South African magnetometer data. And again, precisely 22 minutes after that, in European Space Agency sensors stationed over Antarctica. The pattern wasn't natural. The delay, the shape retention, the path, all of it pointed to one chilling conclusion. The signal was travelling inside Earth's magnetotail, surfing the very boundary of our planet's invisible shield, and it wasn't losing integrity. In fact, it seemed to be improving with each cycle, almost as if it were learning how to propagate more efficiently. At this point, one hypothesis began to circulate quietly among the defense sector physicists. What if 3i Atlas wasn't just passing by Earth?